Alright, so welcome to this video. This is a numerical from the topic of electrostatics potential. And what we will do is, it's more of reasoning. And before I start this, I urge you to please subscribe to my channel. I have made around 2000 videos. I need a little bit of encouragement from all of you. The channel is being viewed across the globe. So, United States, India, Portugal, United Arab Emirates, and Philippines. These are the 5 countries my channel is being viewed. And the level of subscription is low. People see it. And my request is, let's do something to encourage me. If you are one of the beneficiaries of this channel and you haven't subscribed, please do subscribe. And let's go forward and do the numerical or the reasoning question. I'll just rub this off, and let's discuss this question in depth. Don't forget to subscribe. And all right, so this question is about something called as a Jacob's ladder. Okay, and what Jacob ladder is essentially these two wires which you see, and these two wires are these two wires, right? So you keep two wires, and what you do is you use these wires to produce an arc. Let's see what you do. So what you do is you keep this wire number 1 and wire number 2, and you can see this in the diagram, right? And then you connect this to a source of potential difference. Now what happens is, if you apply something like 10,000 kilovolt, okay, you apply 10,000 kilovolt at the bottom part, which is this, okay. So this is the bottom part of your Jacob's ladder. So what you've done is you've applied a voltage which is around 10,000 kilovolts. Okay, this is a very high voltage, 10,000 kilovolts. Sorry, it's 10 kilovolts or 10,000 volts. And all right. So the good part is this is narrow at the bottom. So you have this as a narrow, and this is pretty wide. Okay, this is very, very wide. Okay. Now the question is, once you apply the voltage, what is seen is that there is an arc, and this is curved, right? You can see the curved. So both are curved, right? And the space upwards is high, and the gap between them is low here, right? So it's low gap here. What is seen when you apply this voltage to these two curved, the wires is, or the rods, is that there's a generation of an arc here. You can see this arc. So there is an arc which is developing here, and then this arc travels upwards like this, and then it finally it vanishes here at the top. So the question is, what is happening that a spark is getting generated here, right? A spark is getting generated. That's question number 1. What is this spark all about? The question number 2 is, why the spark goes up? Why is the spark traveling upwards? And then at the top, the spark vanishes, as I mentioned. And once it vanishes, the spark again starts from the bottom and starts traveling upward. Right? This is pretty weird, right? That this is happening repeatedly. And so we need to give a physical explanation, a reasoning as to why this is happening. Okay, so let's talk about the part number 1. Okay, I'll just bring on some color, which is easy. All right, so let's talk about when the voltage is applied. So you have this wire, the gap is narrow here, and then it increases. You have air here, right? Air. And then you have potential difference, which is applied across these 2 points, or across 2 curved rods. And this air then, what happens to this air is it breaks down, right? Once the air breaks down, air is an insulator, right? So air is an insulator. The air breaks down, and the insulator, which is the air, gets converted into a conductor. Okay. Now, which means the place here, between the two rods is now a conductor, and a conductor always allows current to flow. So you have current flowing between the two rods. So these two rods practically, there is to start with, what you have is a spark. Spark as in the spark plug you have in the car, based on the same principle. The air breaks down, right? So you have something called as dielectric. You can see my videos on the dielectric to understand the breakdown of air. The air breaks down in presence of very high voltage. It loses its insulation property and gets converted into a conductor. And once you have this insulator, getting converted into conductor, there's a free flow of charge from, one wire to another. And then this air becomes a conductor and the current starts flowing. This current which starts flowing in the air is called as nothing but a spark. Okay. Now the spark has been generated. Okay, you have a spark here. I'll convert the diagram into a spark. And the air, which is there, gets heated also, right? So the air here is getting hot, and the hot air always travels upward. As the hot air travels upward, since it is ionized, the spark travels with the hot air. The hot air travels upward. The spark also travels upward, because spark is current, and current would always like to flow through the channel of minimum resistance. It finds that as the spark is climbing upwards, the resistance is getting lower, right? So instead of being here, the spark prefers to stay here because the resistance is very low here. So therefore you see a climbing up spark between the two rods. So this answers your question number 2, why the rod has the spark going in between, up in the upward direction, right? So the spark is traveling up because the air is very hot, and the air climbs up, the spark tags along because it has to find the path of minimum resistance, which is nothing but the ionized air. And then at the top, the distance becomes so large that the spark is no longer able to maintain itself, right? It's no longer able to maintain itself. And so long you have a spark which is existing here, the potential difference between these two rods is very small, or 0 volts, because they're connected to each other. Like this is like a short circuit, right? So if you have two bodies which are connected to each other, the current is flowing between them, and practically the voltage is very low because now you have connected them. And so the voltage is going to become 0 when it reaches at the top and the gap is very high. The spark is not able to maintain itself at the top place and the voltage is 0, right? So the spark goes away, and at that point of time, the voltage between the two rods here, the potential difference is practically, approximately 0, right? Is equal to 0. What does that mean? It means that once the spark goes away, the potential is no longer equal to 0, the potential difference between the two rods, rod number 1 and rod number 2. And therefore, again, the potential starts building between the two rods coming from the source of potential. Okay? Which means, again, the process will repeat. Again, the spark will travel upwards, showing, an exaggerated view. And then again, the potential difference becomes 0. The spark is there, and beyond a certain point, the spark vanishes, and the potential, is again back to square one. The potential starts building from here, and again, you see. So this answers your question number 3. Why does this new arc appear only after the previous one is gone? Because when the previous one is gone, delta V is equal to 0 is not true. The potential difference, is no longer equal to 0. And therefore, we have a source which starts building the potential difference between the two rods again. So I hope this made sense to you. This is pretty practical, an example. If you're sitting in United States, you're in UAE, you're in India and watching my videos, please do subscribe to my channel. And please encourage me. I need some subscription to popularize the channel. And I will come out with some fantastic videos. That's my assurance to you. Please do subscribe. And thank you very much for your time today.